to our advisor, Dr. Gino Andres, to the honorable members of the board, ladies and gentlemen, good day. Today we will be presenting the final output of our project entitled HHO Generator, Plausibility of Acrylic Glass Frame and Cooling Tubes as Thermal Reducers on Producing Efficient HHO Fuel for Automobiles. Today, the Philippine government forces automobile manufacturers to seek probable ways and improvements in fuel efficiency and gas emissions due to nerve-wracking increase in global temperature which yields the greenhouse effect. According to Going Green, an international agency that evaluates carbon dioxide emissions in different countries globally, Philippines have emitted over 132 million last January 11, 2019, to 127 million a year ago, a whopping 3.79% increase on carbon dioxide emission. From this increase on carbon dioxide emission, the researchers have envisioned to produce a system capable for running an internal combustion engine and maintaining a low temperature for prolonged production of HHO fuel, which will play a role in the reduction of greenhouse gas emissions and reduce dependence on imported fossil-based fuels. On this project, we will be making use of cooling tubes and acrylic glass frame, which will be further discussed on the following slides. There are three main objectives for this project. First is to stabilize the temperature and to show the significant effect and difference upon the application of acrylic glass frame and cooling tube to the generator. Second is to stabilize the production of the HHO fuel, and lastly, to become automobile efficient. This project has two targets. Number one is the automotive industry. Emergence and development of alternative fuel vehicles as well as systemized vehicle catalytic conversions have been regulated for future improvements. Alternative fuels for automobile applications include natural gas, propane, hydrogen fuel cells, and even electricity. However, although promising results can be seen in the use of these alternative fuels, innovations are required before being commercially feasible on automobile industry. And second is the fuel and energy industry. The increase of world's dependency on fossil fuels comes with the soar of global release of harmful gases such as carbon dioxide. With the innovation of having hydrogen gas as a fuel, toxic emissions are emitted or lessened. The challenge of this is the reliable, cheap, and stable source of hydrogen gas, which is the target of the researchers in this study. Technological advancement further increases probable ways in promulgating the improvement of fuel efficiency and gas emissions on internal combustion engines. Hydrogen generator designs should take ponder on its efficiency, operability, and safety. Since rapid combustion happens in hydrogen generator, a system should be done to withstand with a high temperature given by the source that will provide the amount of energy to generate HHO fuel. Hydrogen and fuel cells is a viable response due to its potential to be an energy system with low carbon emissions. The significant technology improvements makes manufacturing of such systems cheaper than they used to. It opens opportunity for job creation, efficiency in general business, and revitalized economy with high demand and price of agricultural products. The versatile and flexible uses of hydrogen and fuel cells varies from electricity generation, transport, domestic, and industrial uses. This presents a multitude of options when considering the socio-economic circumstances and factors at play.
The HHO generator setup. Modifications were made while making our own HHO generator. Modifications such as the application of acrylic glass frame and the relocation of holes found on the stainless steel plates. However, the arrangement of plates remains the same. Positive plates are still located in front and back of the arrangement and the negative plate in the middle. Flow diagram. The figure shows how the electrolyte, cooling water, and HHO gas flows in the system. Electrolyte flows out from the reservoir into a stainless steel tube located inside the cooling tube. The cooling tube has a pump that regulates the water that flows against the electrolyte. The electrolyte then flows into the HHO generator. Then the HHO generator produces HHO gas that is then transferred into the reservoir and later on be readied for production. Acrylic glass frame. This serves as a thermal stabilizer for the steel plates and holds them in place. As you can see, they come in pairs, an L shape that is then shaped into a square, which is directly bolted in to the acrylic glass cover. Why acrylic glass? As you can see, there are 6 essential characteristics of acrylic glass. One characteristic is its mechanical strength. Fiberglass has a specific resistance greater than steel, so it is used to make high-performance tasks. Next is compatibility in organic matrices. Fiberglass can have varying sizes and has the ability to combine with many synthetic resins and certain mineral matrices like cement. Next is dimensional stability. Fiberglass is not sensitive to variation in temperature and hygrometry. It has a low coefficient of linear expansion. Another characteristic is electrical characteristics. Fiberglass is good electrical insulator even at low thickness. Next is incombustibility. Since fiberglass is a mineral material, it is naturally incombustible. It does not propagate or support a flame. It does not emit smoke or toxic products when exposed to heat. Lastly, thermal conductivity. Fiberglass has a low thermal conductivity, making it highly useful in the building industry. Cooling tube. This is used as a heat exchanger to remove heat from the electrolyte coming into the generator. As I explained a while ago, it uses a water pump that negates the flow of electrolyte which is flowing in a stainless steel tube. It uses water as a coolant, negating the pressure or the flow of the electrolyte reduces the temperature of the electrolyte coming in the HHO generator. What is the significance of acrylic glass and cooling tube? All throughout the experiment, it recorded the lowest temperature, measuring a mean of around 36 and 110 degrees Celsius. The acrylic glass frame HHO dry cell with the cooling tube attained the lowest temperature stability among 3 setups. It also recorded the highest LPM production, measuring a mean of 3.3 LPM or liters per minute. The acrylic glass frame HHO dry cell with the cooling tube attained the highest production among 3 setups. We conducted 3 experimental setups all throughout our experiment. 1. With cooling tube and with acrylic glass frame. 2. Without cooling tube and with acrylic glass frame. And 3. Without cooling tube and without acrylic glass frame. Temperature. The graph above shows how the presence of the acrylic glass frame and cooling tube affect the negative and positive terminal temperatures. As you can see in the negative side temperature difference graph at the left, the acrylic glass frame HHO dry cell with cooling tube recorded the lowest temperature among the 3 experimental setups. As well as in the positive side temperature difference graph, the acrylic glass frame HHO dry cell with cooling tube again recorded the lowest temperature among the 3 experimental setups. Volumetric flow movement production. The graph shows the distribution of liters per minute production of HHO fuel due to the absence and presence of acrylic glass frame and cooling tubes. As you can see in the graph above you, the acrylic glass frame HHO dry cell with cooling tube recorded the highest LPM production of the HHO fuel. The significance of the liters per minute production is it controls or it shows how efficient your HHO generator system is.
The results can be seen from the graphs which contains the data produced by conducting experiments. It has showed a significant difference among the three setups. The setup with acrylic glass film and cooling tube recorded the lowest temperature and highest LPM production. The study has also shown a significant relationship between the LPM production and temperature changes in different terminals. The higher the temperature in the terminals, the lower the LPM production is. So it is important to stabilize the temperature in these terminals to maintain the best LPM production possible. Inhibition of the system. Based on the results, the acrylic glass frame and cooling tube has significance with the performance of the system, with its capacity to let the system have a stable temperature and a high volumetric flow movement production. The researchers also suggest that the H2 and O2 gases produced by the generator should be separated. Positive plates produce O2 gas, while the negative plates produce H2 gas. With this, further research should be on the separation of these gases, focusing the hydrogen gas as a fuel additive for automobiles. The graph has shown the significant relationship between the temperature of the terminals and the LPM production, so it is important to maintain a good cooling system. Cooling tube reservoir. The researchers found out that there is inconsistency in the temperature of the cooling water. They recommend to insert another water reservoir that supplies additional water coolant to the cooling system. We must move away from our dependency on fossil fuels, and I am glad that the global market has invested over $1 billion in hydrogen fuel cell cars to meet this goal, a quote by Albert Quinn from 2017.